So from our point of view this year, we are very focused on watching what is going on in both the developments of the LEO constellations, and also we continue developing our products for both MEO and GEO in terms of the new frequency ranges that we're seeing on the ground segment, which is for ETL the most important part of the satellite network. Obviously, launching satellites, whether they're low Earth orbit or GEO, is very sexy, but unless the signals go effectively up and down from the ground, from teleports, they're pointless. So for us, it's all about providing the ground segment equipment to pass efficient RF distribution to whichever the customer is. Certainly from a LEOsat point of view, we are looking at modifying some of our RF switches to link into the new antennas, which we are still waiting to see what their designs will be. Obviously, we're very experienced in dealing with geosats, where we're using standard parabolic antennas, and we're getting some very good frequencies, very good signal levels within L-band, and therefore we're able to switch and provide a very good seamless link to uplink and downlink those signals for broadcasters and other customers as well. So our matrices, amplifiers, and fiber links are all very much ready for that. So whether it's going to be a phased array antenna system for LEOsat, or it's going to be a parabolic antenna system, or it's going to be flat panel, it's going to be quite interesting to see what requirements they will have in terms of signal quality and frequency range. I think the introduction of a LEO constellation, whether it's a large 3,000 satellite system, or some of the smaller ones which I've heard about this week could only be 60 satellites big, certainly going to mean that we're going to have to modify some of ETL's well-known RF matrix switches to be very much faster switching. So at the moment, a lot of our matrix switches switch signals at about 50 to 100 milliseconds. As a LEOsat network comes overhead and the antennas pick up the various various satellites and then hand over, we may have to be switching at nanoseconds. And we're very much waiting for the ground segment design to be able to respond to those requirements. But for us, it's very much building on our experience as an RF manufacturer in handling RF signals. And certainly what we're seeing in the MEO and GEO world, working with higher frequencies, is making sure that we are switching now up to 4 gigahertz, and we're seeing a push up from standard L-band, which is between 1 and 2 gig, now up to 4 gigahertz as well. So it's a modification, really, and different countries and different licenses will have different bandwidths. So we have to encompass in our switches redundancy on fiber, very much all those frequencies as well. I think the major downside, it was something that I mentioned on at a conference yesterday, was very much the fact that because the LEO networks are seen as a budget solution and data is driving satellite at the moment, which seems to be very much a focus away from AV use, is that there will be a mindset that ground segment should cost nothing as well in proportion to the satellite. So I think the requirement to design good ground segment equipment means that people are going to have to invest in that. But it's all very well throwing 3,000 cheap satellites up there, but you can't do the same on the ground, because fundamentally it's still going to require redundancy, some very interesting switching solutions, and therefore from our point of view, we may have some very big price pressures to try and achieve new technology, and I think that is probably a big threat for us, because we don't yet know what the ground segment is going to look like but I don't think we can do it in a sort of budget $3 solution that I have been hearing in conversations I've been having with some of our customers here in Singapore this week.